And we and
Sorry, I don't want to butt
good.
in. So it's really fascinating and a bit humorous to hear you say, never in your wildest nightmares would you have envisioned the lack of privacy that we experience today in the Web 2 world. So, given that you all had such great visions for what would become the internet, what went awry that eventually led to the web being so invasive and just lacking in privacy?
So, uh, so part of why it went awry was actually, I'll say, my fault, or primarily my fault, which is uh, in 1989, Dean and I both left Xerox PARC to help to form the newly funded Xanadu project. Um, uh, uh, Xanadu had been going on unfunded on a shoestring throughout all of this time until 1989, when Autodesk decided to fund it. We then formed this really wonderful uh, um, startup to build out to really build the Xanadu hypertext system. And there were two things we got wrong. One was I tried to we had a notion of what features you needed simultaneously to have a hypertext system that would create good social emergent effects. There were basically 7 fundamental requirements. And this is laid out in my paper, The Open Society and Its Media, is what those 7 fundamental requirements were. And as and we built a system that did those, but it took us longer than was expected. And we kept having these triage meetings where we tried to figure out if we could drop something in order to get to market faster. And we kept talking ourselves into the fact that, well, if you drop these things, you get social pathologies. So you really need all 7 in order to get the kind of beneficial emergent social effects on the evolution of society's knowledge that we were looking for, that were motivating us. And as a result, the project went long enough that Autodesk, our funder, ran out of patience, well, partially due to a management change at Autodesk. So we were already in beta with the product. It was not in beta. We already had the features working. We were demonstrating we had the features working, all 7 features, but it was quite a long way from really having been something that was a commercially viable system at that time. By the time we ran out of funding, the other thing we got wrong is none of us appreciated what we would now call open source, which was then called free software from because Richard Stallman's way of explaining the virtues of free software didn't make sense to us. And it wasn't until later with the open source movement that we really came to understand the power of it. But the result of those two things is that we built something where the technology itself was quite intricate and needed a bunch of work before it could be used commercially. And it was proprietary. So without funding, it was hard to figure out how to continue to advance the system. The web came out with 2.5 of our 7 elements, and took the world and was a simple architecture and was open source, simple enough with text-based protocols, which is still kind of insane. Text-based protocols so that people were able to put together web servers on with very, very little software, which itself is quite wonderful that you could do it so simply. But with 2.5 of the 7 elements, it proceeded to have all of the social pathologies that we were worried about. In my paper, The Open Society and Its Media, there's 2 paragraphs in that paper that I would say really explain pretty damn well what we then later came to call filter bubbles and echo chambers and all of those things. So that's how Xanadu died, and it was in the light of the death of Xanadu that Dean and I then left Xanadu and formed with Norm Hardy and others Agorics in the mid-90s, dropping the hypertext part, but taking forward the liberation goals, the software, decentralized cryptographic software systems, but now general purpose computational systems that could support hypertext and other things, could support just general purpose, decentralized, secure, permissionless programming. If you can support that in general, then any particular decentralized application like hypertext, you can, of course, build out of that. So that was one of the formative elements. Another formative element is I had, what was the time frame here? I'd say probably early 80s. I was a really big fan of object-oriented programming and then of actors. And separately, or thinking it was completely separate, I was also becoming very, very interested in economics, and in particular in the writings of an economist, Friedrich Hayek. And I was explaining, I think I would say around 1983, I was explaining to my friend Eric Drexler about the virtues of encapsulation in object-oriented programming, how for every piece of data that it's encapsulated within an object, so that with regard to the there's only a finite amount of code that you have to look at to know whether the invariants are being maintained in the data, that this coupling of encapsulated data together with code. And Eric said, oh, that's like Hayek's explanation of why property rights are important. And that was the big aha experience that brought the thinking about computation and the thinking about economics together in my head, realizing that they were, at an abstract enough level, solving the same sets of problems in the same sets of ways. That the way I would, the way I've been putting it, since then, or more recently, is both large object programs and the human economy as a whole are networks of entities making requests of other entities, and that the nature of the request making is the request contains both an informational component and a rights and incentive component. That there is the transfer of information in the request, but also the transfer of rights. So this really led to. So it was from 83 to 88 that Eric and I worked on the Agoric Open Systems papers published in 88. And that very much caused me to see the foundations of the economic issues just very directly in language-based terms. And that's what led to the appreciation of capabilities, which is capabilities are the rights that are transferred in a request from one sovereign entity to another sovereign entity. And that's, seeing that from the object-oriented perspective and seeing that from the economic perspective, the only kind of economics that you can map to object-oriented computation is one that recognizes the object reference as the right. So it very much led us to a much deeper appreciation of the capability perspective, sort of the only perspective that supports decentralized rights ownership and rights transfer as the foundation of computation.